Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy other type of puzzle. It's not a Sudoku puzzle, and it's called Topo Map by Michael Lefkowitz. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. So this is a totally different type of puzzle. It's called Topo, which I believe Michael Lefkowitz basically created. So let's get to the rules. We have Topo rules, where we need to draw lines so that the grid is separated into regions. Lines may not branch or intersect, and some lines are given. So lines cannot branch. So you cannot do something like this or intersect, which means also do something like that. So interesting. So that the grid is separated into regions. What does it mean that you can't branch? Because the thing is, I'm so confused by that. Lines may not branch or intersect. What does that mean? Because the thing is, to have a region, you're going to have to basically do something like that, right? I don't know. Huh. Maybe we can get some more information on this. All cells of a region must be filled with the same digit. And digits in regions that touch differ by exactly 1. I don't get this. I really don't get this. We have so we have I'm so confused by this, right? Digits in regions that touch differ by exactly 1. The clue on the line is the value in between the digits it separates. For example, 2.5 would separate 2 and 3. Right, but I'm so confused by what... Like, wouldn't this be a region of size 1 here then? I don't get how this is 4.5. And how do we draw lines so that the grid is separated into regions, but lines may not branch or intersect? I'm so confused by this. Hold on. I'm going to pause and take a look at the examples. Or actually, maybe we can just look at it together. Well, I'm going to... Okay, the example here... Grid is separated into regions. Okay. I am so confused here. Lines may not branch or intersect. Some lines. So what's confusing to me is isn't this line like intersecting with itself here? I'm so confused. Because in the example, we don't have lines actually intersecting. So that actually makes sense. But isn't this line like just sort of intersecting itself? I'm so confused by this then. Oh, okay. Well, one thing that is the case is digits are not the size of the region. So that's helpful. But yeah, I'm still really confused by this. Isn't this line intersecting with itself? So how does that work? Or is it? I'm really confused here. I am so confused about how this is not intersecting itself, or this is not intersecting itself. Or it's just a separate region by itself. I guess that could work. Okay, so I think I understand. So, okay. I'm so used to Philomeno, where basically the digit is the size of the region. But the digit here is not the size of the region. The digit here is basically you just have a digit there, and you place a digit in the entire region. And I guess this is not considered intersect. Oh, it can't branch or intersect, but that means to intersect you must intersect with another line. So I guess it's not intersecting with it. You can't intersect with itself because it just completes itself. Interesting. So a clue on the line is a value between the digits that it separates. So this line means that the digits it separates must be 4 and 5. Because, and same with this must be digits 4 and 5 here. This has to be, so I think this says that means that both of these must separate from these, and these must be 5 and 6 as combinations. So each region has to be filled with the same digit, but that digit does not have to be the size of the region, so keep that in mind. It's basically just a number. And any regions that touch each other, which means I think share an edge with each other, must differ by exactly 1. Right. Yeah, and those are all the rules. So to clarify, the digit that's in the region, it must be populated with the same digit if it's all a region, which means that it's orthogonally connected. And it does not have to match the size of the region. And any regions that touch each other, which means share an edge, must differ by exactly 1. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we know there's no... This cannot branch, so none of these are lines. To form a region, then, we're going to have this go there. Because otherwise, it's just going to be an open... This is going to have to connect to here, and then this line doesn't really form a region. Same here. This cannot branch. This cannot branch. These can't branch. Okay. This can't branch. So one of these is 0, the other one is 1. These cannot be lines because that would be considered branching or intersecting. So we know these are 0 or 1. These have to be all in the same region. So this is 4 or 5. These are in the same region here. So this is 4, 5. This is 4, 5 here. 4 or 5. These have to be 5 or 6 because they are in this. These are going to be in the same region, definitely, because there's no possible split there. So here, these have to be the same region, right? This is all one region. And let's make that orange. And this is pink. Therefore, this must be the same pink, which means this must be orange here. Between the digits, it separates, so it's all the digits. So then this must be orange also, and is 4 and 5. This then cannot close off, because then this would be different regions. They would have to differ by 1. So, right, this is 5 and 6. This must differ from 5 or 6 here. This has to be 4 and 5. So this is matching, we'll make that green, and this is red. So therefore, this must be the same digit as this. This is a different region, so therefore it must be blocked there. This has to be 5 and 6 here. This has to be 8 and 9. Okay, we have 0 and 1 here. Light and medium. How does this work? Well, How does this work? This is 1 at most. This is 5 at least. So therefore, to connect to this, it has to have a difference of 1 each time, right? If it shares an edge. So therefore, doesn't this have to be line, 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 line? This would then have to be 1. Then you'd have 2, 3, 4, and 5. So red has to be 5. Green has to be 6. Oops. 6. And these are all 1, which makes this 0. So we have to have similar here, right? Because you can't jump in size. So therefore, this is line here, line here, line here, line here, all the way to here. So this is 2. That's 2. This must be 2 because lines cannot intersect. Well, that's not true. It could just basically be... These are 3. These are 4. These have to differ again. So this has to be balance here, which means these are 8. And this must be 9 here. This is 7, 6, that's 5. This is 4. So this must difference between a 5 here to be sharing an edge. This is 8, 7, This one we don't know. This one had to go 1 through 5 because it's otherwise too big. This has to be 8 going to 6 here. So this is 6, and this must be 5 there. So then we have 7 here and 7 here. We have 6 there, 6 there. So since this is 6, you don't know what shade this region is. This could go 8 here. So what are the digits that could be next to each of these? This is next to 5 or 6. So this has to be 5 or 6 here. This is 4, which could be next to, it could be 4 itself or 3 or 5. But 3 is not consecutive with 5 or 6, so this must be 4 or 5 here. This is 4, 5, or 6 there. This is 5, 6, or 7. This is 6, 7, or 8. This has to be 7 or 8 to be next to the 7. This could be 5, 6, or 7 to be consecutive with the 6. 5, 6, 7, 5, 6, 7. 5, 6, 7, 5, 6, 7. It can't be 7 here. None of these could be 7 because if they were 7, that would be not consecutive with 4 or 5. That's 5 or 6 there. These have to be 0, 1, 2. 1, 2, 3, 2, 3, 4, 3, 4, 5. This can't be 3 because that's not consecutive with 5 here. This can't be 2 because it's not consecutive with 4 or 5. No 1 here because it's not consecutive with 3 or 4. No 0 here because it's not consecutive with 2 or 3. Consecutive with 4 or 5 could be 3 through 6. 3 through 6, 3 through 6, 3 through 6, 3 through 6, 3 through 6. This cannot be 3 because that's not consecutive with 5, 6, or 7. If this, okay, this digit is consecutive with 0, 1, 2, so it could be 0 through 3. Well, that's not consecutive with 5 or 6, so this is 3 or 4. 3 or 4 is not consecutive with 0 or 1, so we have 2 or 3 there. 2 or 3 is not consecutive with 0, so this is 1 or 2 there. These must be 4 through 8. 8 is not consecutive with this digit here, so this can't be 8. This digit has to be next to 4 or 5. 3 is not consecutive with 5 or 6. It's 4 through 7 here. No 7 here because it's not consecutive with 4 or 5. This digit's consecutive with 1 or 2, so it's 1, 2, 3, 2, 3, 4, 1, 2, 3, 4. I guess this could be 0. 2, 3, 4, 5, 3, 4, 5, 6. This is 5 or 6 to be consecutive with 5 and 6, or be the same as 5 or 5 and 6. So this can't be 3 because that's not consecutive with 5 or 6. No 2 here is not consecutive with 4, 5, or 6. No 1. No 0. This can't be 5 or 6. That's not consecutive with 1, 2, or 3. This can't be 6 because it's not consecutive with 2, 3, or 4. Okay. These cannot be boundaries because that would be intersecting or branching. So these digits are all the same region, and therefore they have to be all 3. So this is 3, therefore this is 2, that's 1. This must be 2 here. Actually, no. This doesn't have to be 1 or 2. This is definitely 2, though. And to form a line without intersecting or branching, this has to go that way. So then this goes that way, therefore this is 2. So this is 2. The orange has to be 4. The pink is 5. So then we have a line going that way. This must be 2 because it cannot intersect. This is different from that, so this must be line completed there. Therefore, this is 3, which makes this a 4. This can't be 2. It can't branch, so this must be the same region as that. So this can't branch, no branching there. This is boundary, boundary. This has the same region as that, so this is 3. This can be consecutive with 3 or 4. This is the same as that, so this is 3, which is consecutive only with 4, which makes that consecutive with 5. So then we have to have a line there, line there. These are all 4. These to be consecutive, this has to be 5 here. And then that's 6. So we have line there, line here. This is not 4, so and it's not 6 because it's not consecutive with 4. So this must be 5. We don't know. So this is consecutive with 5 or 6. So this can't be 7. This must be 3 or 4 here, 4 or 5 or 3 there. 4, 5, or 6 there. 5 or 7 there, because it cannot be... And 7 is not going to be consecutive with 4 or 5, or the same as 4 or 5. So this can't be 7, this is 5. So we know there's a line here. Therefore, and we either, this is 5, which means this closes off there, or this is 6, which means, oh, cannot. If this is 6, that means 5 has to go this way. That would form there, but then this would be considered it would be considered branching. So this is definitely a line. This cannot be 6. It must be 5. So this is a circular line there. This cannot branch this way or this way, so this is the same as that region. This cannot branch this way or that way, so that's the same region. So this is 5. We have 5 there. This must go there. This cannot branch here or here. So this must continue there, because this otherwise it can't go any other direction. So this is 5. This is 4 or 6 here. This is 5. This cannot be 3, so it could be 4 or 5 there. 3 or 4. This can't be 6. None of these can be 6 because it's next to a 4. And that would be either 4 as the same region or 3 or 5 if they are consecutive. This is the same region as that, so it cannot be 4 here. It must match this. This, well, it could, okay, so it cannot, this cannot close off this. If it connects to this, the problem is, it's basically, yeah. Well, can it? Maybe. I don't know. I'm not sure how this topo really kind of works. This can't be 6 because that's not consecutive with 8. This can't be 5 because that's not consecutive with 7 or 8 there. Therefore, this is different than, it has to be 6 here. So this is 6, which means the line has to go that way. This has to be 7 to be consecutive with both 6 and 8. So that's 7, which means this is lined that way. This is lined there. This cannot go this way because that would branch. So that's not possible. So these are the same regions, which means these are both 6s. This could close that way. Hmm. Interesting. Remaining digits here. They're next to it. This has to be 5 or 6 because it's next to a 5 and a 6, so it's the same as one and different and consecutive with the other. This can be 5, 6, or 7. 5, 6, or 7 there. It cannot be 5 because that's not consecutive with 7 there. This can't be 4 anymore because that's not consecutive with 6 or 7. This can't be 7 because that would be not consecutive with 4 or 5. So these are the same. So it's 5 and 6. This then is only 6 because it's consecutive with only 7 here. So this is 6. These are the same. So that's all 6, which makes that 7. This then must be line here. It must be line here. So this is not line here because you can't branch. And this is not line here. So these are all 7, which necessitates this being a line. So this is 6 or 7 to be consecutive with that. To be consecutive here, it's 5, 6, or 7. This cannot be 3. This has to be 5 here to be consecutive. So therefore, this line continues that way. This can't branch, so therefore this must go that way. And therefore, this is the same region as that, so this is 5. This must be 4 or 5 to be consecutive with this. These must be boundaries there. Um, 7 is not consecutive with 4 or 5. So it cannot be 7. It's 5 or 6. This digit must be consecutive with 4, 5, 4 and 5, and 5 and 6, which makes that 4, 5, and 6. Okay. How does that work? If we close off here, then this would be 4. But this would have to continue on here. I think, right? So if we close that, this is obviously not part of it. So this would have to continue. And then you would have 4 here and 6 here, which is not possible. So this cannot be closed. This has to be a 5. This can't be 5. It's consecutive with 3 or 4. There has to be a line continuing that way. if we close off this, we have the same problem, right? This has to be 5 to be consecutive with 6, and then one of the same regions as 5. But then this has to continue on this way because this line cannot branch. So therefore this would be 7, and that would break that. So this has to be 6 that way, which means that's different. Therefore, this can't be 4. It's 5 or 6. Can we close off here? I think we have the same problem, right? If we close this off, that becomes 4 there. This cannot branch, so therefore these are the same regions, and therefore this would be 4 next to 6, which is not going to work. So this must be 5 then. So this is 5 also. And we know this has to be a boundary here because of the 3, 4. So then this has to, well, we don't know. So this is 5, this has to be 4. Well, this can't branch anymore. So no more branching for that. So this must go this way, which makes that a 4. No branching here, so this is 4 there. This has to be 5 to be between 4 and 6. So this is done as a line. Cannot branch. So this is part of the same region. No branching, so this must go that way. This is then 5. This has to be different, so it has to be 6. So then this must be that way. So then this is 6. And that's how you draw it. Interesting. Yeah, I guess it's kind of intuitive about where things can be because of the branching nature. So having the X's was very useful for basically figuring out where things could and couldn't be. And then you just try things, right? So if you say, hey, if I cut off this line if I basically connect that line, what happens? And then you basically don't cannot branch, so therefore that region would have to extend, but then this would have to be going down by 1, so it'd have to be part of the same region as that, which would make that 4. So that's pretty interesting there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.